A minha alma tá armada e apontada para a cara do sucesso. Os pais sem voz, pais sem voz, não é paz, é medo.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. That is Minha Alma, probably not pronouncing it correctly, a Portuguese tune that I happen to like. It translates to my soul, and my soul is the calculus we are going to integrate using substitution. Thank you, Sir Isaac. Thank you, Gottfried. Okay, so let me just take you through a little something here. We've learned some rules for integration, but our rules don't cover many of the complex functions, more of the complex functions. So, for instance, what if we came across something like, ooh, that's a horrible integral sign. What if we came across the integral 2x square root 1 plus x squared dx. We do not know how to distribute that nicely, okay? So what we're going to do is called substitution, okay, to make the integration easier. And there is a strategy to this, and you will get better at it as you do more and more of these. Now, I'm going to choose to let u equal 1 plus x squared. 1 plus x squared. Okay? And then I'm going to take the derivative of it. The derivative of u is equal to 2x. And what we haven't been doing after taking the derivative is writing what the derivative is with respect to. Well, the derivative is with respect to x, dx. Okay? And we haven't been writing this dx because it just gets in the way. We don't need it, and it gets in the way because we often did other things with our derivatives that we would go on to solve them. But the derivative of u is, if u equals 1 plus x squared, is equal to 2x with respect to x. Okay, so du equals 2x dx. Now, I'm going to rewrite this real quick. Okay, this is multiplication here. So I'm going to rewrite this as 1 plus x squared dx. I'm sorry, 2x dx. Okay? I just changed the order of multiplication. With this substitution, I can now rewrite this as the integral of the square root of u, because I let u equal 1 plus x squared. Right? And now, since I took the derivative, du is equal to 2x dx. So I am replacing 2x dx simply with du. Okay? And all of a sudden, this is an integratable function. We can integrate the square root of u. That equals the square root of u to the 1/2 du, and we simply have to use our power rule, which would be equal to u to the 3/2 divided by 3/2 is 2/3 plus some constant c. Okay, and then we just have to substitute back in what we know for u. So that's going to be equal to 2/3 multiplied by 1 plus x squared to the 3/2 power plus c. And so we're saying that the integral of 2x times square root of 1 plus x squared dx is equal to 2/3 times 1 plus x squared to the 3/2 plus c. Okay? So to check that, and just maybe to prove it to you, I'm going to take the derivative of this and show you that we end up with 2x times the square root of 1 plus x squared. Okay, so this is simply going to be a chain rule, right? So if I use the chain rule, I'll do this in pink. To take the derivative of this, then it would be, let's see, 3/2 times 2/3 times 1 plus x squared, and then I subtract the 1, 3/2 minus 1 is 1/2, multiplied by the derivative of the inside function, which is 2x. And I think you're going to see what happens. I'm going to simplify this. 3/2 times 2/3 is equal to 1. And I can rewrite 1 plus x squared to the 1/2 as the square root of 1 plus x squared, multiplied by 2x, which I'll move up front. And I have this exactly. Okay. Now, the secret or the skill, the way to get good at using U substitution is figuring out which function to choose to let equal U. But I think you can see that you want to be able to take the derivative of U and get the other function, or to get the form of the other function that you can manipulate. Okay, so let's try a couple of examples. All right. Oh, the rule that we just used, sorry about that, the substitution rule formally states if I let U equal g of x, and it's a differentiable function whose range is an interval I and f is continuous on I. We always have to put that in there, that the function is continuous. There's no holes or breaks in it. Then the integral of f of g of x multiplied by the derivative of g of x dx is equal to the integral of f of u du. And so that's what happened here. We just generalized it. This is the integral of f of u du, where f of u is equal to root u. Okay, so that's the substitution rule. And let's try an example. Okay, use substitution to find the integral of x cubed plus 2x plus times 3x squared plus 2. So I'm going to use substitution, and I'm going to figure out if I take the derivative of one of these functions, will I get the other one? And I think you can see if I let u equal x cubed plus 2x, then du is equal to, what did I say, x squared plus 2x? I meant x cubed, sorry. X cubed plus 2x. du is equal to 3x squared plus 2 dx with respect to x. And remember, that takes a little getting used to. We should have done that before, but that just means with respect to x. Okay, and we probably should put some parens there. Okay, so now I can say that this, by this substitution, is equal to the integral of the square root, we got that square root again, x cubed plus 2x is equal to u, so that's square root of u, and du is exactly equal to 3x squared dx, which I can substitute in as du. Okay, and again, that's the integral of u to the 1/2 du, which is equal to, as we did before, 2/3 u to the 3/2 plus c, and substituting u back in, then we get 2/3 multiplied by u equal to x cubed plus 2x to the 3/2 power plus c. Easy peasy pumpkin pie. Okay, done. Nice. So the substitution isn't that bad. Okay, let's try another one here. So we're going to do A, and I am going to think along the lines, all right, if I let u equal, oh, it's the same sort of thing. Isn't that nice of them? I'm going to go ahead and let u again equal x cubed plus 2x, because I can see if I take the derivative of it, I'm going to get 3x squared plus 2. So du, the derivative of u, is equal to 3x squared plus 2 dx. That's nice of them to give us two examples with the same functions. Okay, so then this a, I'll put a here so I don't have to rewrite it, equals the integral of, well, first I'm going to do my u substitution. I said u equals x cubed plus 2x. So that's going to be here, right? And du equals the 3x squared times the dx. So I can put the du here, and that would leave a 1 up here because 1 du is just du. Okay? Well, the integral of 1 over u is equal to the natural log of the absolute value of u plus c. And then I just replace what I got, what I substituted for u, right in there, and that becomes the natural log of the absolute value of x cubed plus 2x plus c. And we are done till our daddy took the T-bird away with that example. I'm going to stop and make another video, and we shall be right back. I've done all the damage I can do.